here and talk about what it would take to solve this problem for the information in these triangles. And how I'm going to do this, which is a little different than I did this second and third, is I want to give you a procedure. And in this procedure, I want it to work for every different type of triangle situation that you could face. But it basically boils down to two different situations. A situation in which you've been given one angle and a side, and a situation in which you've been given two sides. That's going to be the situations that you will face. And it could be any one of the sides. So I will assume that you know very little, but know a few things, okay? Now, I would take the notes we're about to take on a separate sheet of paper or a separate place in your notes. Call it an appendix. This would be appendix number 2. And I would label it Trig. For the next couple of quizzes, I will allow this part of your notes, even if it's on your tablet, to be visible while you're taking your quiz. Because I don't want the trig to be part of our problem. You follow what I'm saying? So the trig doesn't get you any points, but if you can't do the trig, you can't do the problems. So here we go. I'm going to add a page. Practice, the triangles are already there, but in future, multiple angles, 3 of them. One of them is the right angle, but the other 2 are the angle of focus. But you can only focus on one angle when doing trig. Now you might be given an angle. That seems to be the one that you might want to use for your focus. But the other one, the other triangle, no specific angle was identified or given to you. One of those angles might be better for you to use because of the way the problem is set up. But you have to choose your angle of focus. And once you've chosen your angle, let's look at this triangle, okay? And just do those 3 steps. The triangle's already been identified for you. So we need to identify the angle of focus. Are you guys all good in using the 25 degrees as our angle of focus? So we're going to call that theta. Now, before I go on, let's take a moment and do a little something here. Sniffle, sniffle, sniffle. Okay, so kindergarten, first grade, got paper that looked like this. So things like P, maybe H, A, right? You learned how to write? There's gonna be a lot of Greek letters in here. So every time I introduce a new letter that you've never seen before, I always kind of find it beneficial to go back old school and talk about what it should look like on your paper when compared to other things. Theta is, we're using lowercase theta. So it's gonna look something like that. It's tall, like the H is, but has this little swooshy part. So when I write it, I wrote a bunch of them that would look like that. That's what theta is supposed to look like. So when you're drawing it on your paper, that's what it should kind of look like. Typed, it tends to be symmetrical looking, like that. So if you see a typeface version, it'll look more like that. Uppercase is a full circle with a bar in the middle. So we're looking at lowercase theta. It is very traditional to use theta as something that represents an angle. If you have more than one angle, you'll sometimes use theta in phi. Phi is a circle with a line through it, but it's a smaller symbol and should be drawn that way when compared to your other symbols. Does that make sense? So we'll use that kind of stuff a lot. We have a lot of Greek letters. I need to make sure you know how to write them all. All right. So we're going to label our sides based on the angle of focus. The 25 degrees is our angle of focus. So that means that's the opposite side because it's all the way across from the angle. So opposite. Now there's 2 sides that are next to the angle, but the longest side is the hypotenuse. So the other side is the adjacent. I assume you know how to label your sides. All right. Next, over here, we're going to write them all out. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. I've written them out. I've left some spaces, but I've written them out. So I have the opposite side. So every place where I wrote opposite, I can put in the value for the opposite side. I have the angle. So for all of the functions, I can put in the angle. All right? Now, no problems so far? Pretty straightforward? Any questions to this point? All right, here's where, so coming back over here, this is the only time that you need to stop and check and make sure your calculator is in degrees or radians, depending on the situation. For us, for the time being, everything's going to be degrees for a while. So start with degrees. I have sine of 25 degrees. So hit sine of 25, and I get 0.4226. Cosine 25, 0.9063. And tangent of 25, 0.4663. Now, if you guys have those fancy calculators, you hit the sine button first, and then put in the angle. If you don't know how to change it to degrees or you don't know how to check, hit the mode button. When you find the mode button, you'll get a whole list of things you can change. Somewhere along there is angle, and it'll have degree, radian. Make sure you highlight degree, hit enter, and then go back to your work. We all good? This is usually where I have to pause because somebody has technical troubles. We got it all handled over there? You sure? You're what? Oh, skibbity. All right, so once you've done that, then over here, it looks like I can solve this one, and I can solve this one. So that's what you should do, solve them. So I'm going to take and solve for the hypotenuse, which is going to be 74 divided by 0.4226. And I get 175. And then the adjacent side, I'm going to get 74 divided by 0.4663. And I get 158.7. Okay? Now, this is the part where nobody does what I ever ask. But if you've screwed up, you can figure it out right now. Because you have a ratio you didn't use, which says if I take the adjacent number and divide by the hypotenuse number, I should get 0.9063. So if you do that, you can check your work. Now, it may not be perfect because you probably rounded a little bit, but it should be really close. At least 3 digits close. So you can check your work. Also, you now have all 3 sides. Most of you knew how to use the Pythagorean theorem. So you can always use the Pythagorean theorem to check the sides. Now, this is long and laborious, but it works. In the future, you'll probably be able to cut corners, but get good at it first. I will point out that I did not spend any time talking to you about how to get this angle because all of you know how to get that angle, right? What is it? 65. And let's just put a few asides here in case you don't know these things. All the angles of a triangle add up to be? 180. This angle and this angle are called complementary angles. Complementary angles add up to 90. I will use the word, use its complement. All the time, you should know what complement means. Supplementary angles add up to 180. You should know those things. You should know both of those words. They are vocabulary for my class. Complement and supplement. Supplement adds up to 180. Complement adds up to 90. All righty. Let's get a start on this guy. first, what's my angle of focus? What would you like it to be, the one on the left or the one on the right? Left it is. First one to speak gets it. So we've chosen our angle of focus. After I've chosen my angle of focus, what do we do now? Label the triangles. So opposite, adjacent, hypotenuse. After I've labeled my sides, what do I do? Write all three trig functions. Sine of unknown angle equals opposite over hypotenuse. Cosine of unknown angle equals adjacent over hypotenuse. Tangent of unknown angle equals opposite over adjacent. Over here, we've got it. Which ratio do we have that's complete? Tangent. So I want to use the inverse tangent of 20 over 25. Now 20 over 25, I will compute first. It's 0.8. So tangent of theta equals 0.8. So theta must be the inverse tangent of 0.8. You guys who have fancy calculators, you can probably type the whole thing in. Just hit the second tan and then put in 20 divided by 25 and then hit enter. But those of us who have old school calculators, we got to do it a little bit wonkier, but it's still going to give us an answer. When I work this out, I get that the angle is 38.66. Now that means all of these are 38.66, 38.66, 38.66. They're all 38.66. Once I have found one of the angles, I have found them all. Now I know you guys were able to get the hypotenuse of this triangle by doing the Pythagorean theorem. What I'm showing you is that the whole thing can be done using trig. For example, now that I know it's 38.66, I can take the sine and get 0.6247. I could use that to find the hypotenuse by using a different trig function. So I'll have hypotenuse equals 20 divided by 0.6247. And I get 32. Again, lots of ways to check your work. I could use the Pythagorean theorem. I could do 25 divided by 32 and seeing if it equals the cosine of 38.66. Lots of ways to check your work. But by the time we're done, we should have the triangle solved. All right. And I'll call this trig. Solving triangles. Whatever you're opening, just get it done. Oh, ripping. Okay. So I'm going to give you a series of steps. And I think that these steps will sound a little bit weird in the beginning, but I hope that what I just did as a primer kind of helps you. Because the first step is you have to identify an appropriate triangle appropriate right triangle that could be used to solve your problem. Now, I'm adding this, this step is the first step, but I've given you the triangles, right? And in your practices, you understand you might have to identify what is the triangle in the problem. This part is, I think, the hardest part for students because they don't understand why they have to do it. but I want you to choose the angle of focus. A triangle is going to have focus. This next step should be easy. Label the triangle. This is opposite, adjacent, hypotenuse. And the reason why I know you all know those words, why I don't have to teach it to you, is because SOHCAHTOA. If you heard SOHCAHTOA, you know opposite, adjacent, hypotenuse. So let's apply those to one of the problems. Write out all 3 trig functions. This is the longest way to do these problems. But in the beginning, I think you guys need the experience. Pretty soon you'll understand you don't have to do all of these steps. But for right now, write out all 3 trig functions. So this is SOHCAHTOA. So, because there's kind of a part B to this, fill in what you know. Diverge, because this works up until this point for every situation, but now it's like a choose your own adventure. You got to decide which thing applies. Do you have an angle? Or do you have 2 sides? The one we're doing right now, we have an angle. So we're going to shift to the part where we have an angle. The process is slightly different from here. So step 5. I want you to compute the ratios. I use the word ratio because sine is a ratio of 2 sides, opposite and hypotenuse. Cosine is a ratio of 2 sides, adjacent and hypotenuse. So when I say compute the ratios, I mean compute sine, cosine, and tangent. You have an angle. So now you need to compute the ratios. Next step, pretty straightforward. You should have a couple of equations that can be solved for an unknown. You should be able to solve 2 of the functions. For an unknown side. So when I look, now choose our own adventure, we have a side issue going on here. So we will have to do things a little different. So side, step 5, look for a complete ratio. Use the inverse function to get the angle that goes with this ratio. Compute the other ratios. From the angle. All right? So look for the complete ratio, use the inverse function to get the angle that goes with this ratio, and then compute the other ratios. So 8. Use another trig function to get the last angle. I'm sorry, get the last side. This should do it. right? This should be able to make it so you guys have a path, a way to solve a triangle. Now, this is going to take you time because you guys aren't necessarily good at it. And this is the longest possible way to do this stuff. I don't want to say that this is efficient because it's not. It's not particularly efficient, but it gets the job done without mistakes. And I want you guys to be proficient. So we have 9 minutes. Let's see if perhaps we can have some success. I know. Sorry to make it hard at the end of the day and all. Let's go with 10. Now let's go with 105. There we go. And we'll do 57 and 94. And I'm interested in this angle. Now let's give you that angle. Let's say this is 72. And let's say I want that angle and this side and this side and this side. All righty. Think you can do it?
Yes.
I am hopeful. All right, so I have put the answers there, tiny, tiny print. So don't look at them unless you're ready to be distracted. In a couple of days, I'm going to have you deal with a problem where an object, say, gets kicked off the top of I don't know, let's just say a building. I don't care. I don't think there's going to be a surprise that it's going to do one of those, right? Land someplace over there. Well, you have to be able to figure out where it lands. Would you agree that this angle probably has something to do with it?
Yes.
So, as you might imagine, part of the object's velocity due to the kick makes it go that way. And part of the object's velocity due to the kick makes it go this way. Agreed? Well, there's an implied triangle here, right? Understanding that triangle is what we're talking about. So although I'm going to be making you solve triangles, it's not about the triangle. It's about you having to figure out where the triangle in the problem is and then using your trig to get the parts of the problem taken care of. There's going to be other problems like maybe I have a sign and it's going to be held by 2 ropes. You know, one rope tied to the side of a building and one rope tied to the awning of a building. Well, you might be asked how much tension are in these ropes. Well, I mean, it should be kind of clear that there's a bit of a triangle here, right? Do you kind of see it in there? It's implied. Because that rope is pulling both this direction and this direction. You follow what I'm saying? So the triangles are going to be part of these problems. But I want you to understand from the beginning, it's not about the triangle. It's about things related to a triangle. So let's go back.